So guys, in a square, this is the diagonal. So if we consider this as a square, so this element are known as the diagonal element of this square matrix. So what is the diagonal elements in this square matrix? 1, 5 and 9. If I ask you that what is the location of 5, that is, what is the location of 5? The location of 5 is 2 cross 2. Why 2 cross 2? Because the number of row 5 belongs is 2, the number of column 5 belongs is also 2. So the location of 5 is 2 cross 2. So the location of 1 is 1 cross 1, and the location of 9 is 3 cross 3. Okay, so when so any element, so suppose I consider I 1, 5 and 9 as A, and I give the order as ij. So whenever in a matrix I equal to j, for a square matrix, whenever I equal to j, that element should be the element of diagonal. So that elements are known as diagonal element. Okay, and this is known as the principal diagonal of this square matrix. Okay, principal diagonal. Only one diagonal will exist in every square matrix. Okay, we will not consider this as a diagonal. Okay, please do not consider 3, 5, 7 as a diagonal. Always start the diagonal from left hand side and end to the right hand side, not from right to left. So this is, remember to start from left to right. So this is known as the principal diagonal, and 1, 5 are known as the diagonal element. Okay, so what is diagonal element? When I equal to j, whenever the number of rows is equal to number of column in this square matrices, then the element of that particular order is known as the principal diagonal element or diagonal element. So let us learn one more thing, that is principal submatrix. What is principal submatrix? Okay, so suppose any matrix, submatrix means the part of this matrix, any part of this matrix whose order is less than the order of main matrix. So the order of this matrix is 3 cross 3. Okay, so order of this matrix is 3 cross 3. So if I made some matrix from taking the element of this matrix whose order is less than 3 cross 3, that is 2 cross 1, 1 cross 2, 3 cross 2, so that element, that matrix will be a submatrix of this matrix. Let us give an example. Okay, so guys, suppose I write 1, 2 and 4, 5. So you can see I take 1, 2, 4, 5. I take this portion of this matrix and write it here. So this is the order of 2 cross 2, which is less than 3 cross 3. So this must be a submatrix of this main matrix. Okay, so any matrix whose order is less than that of the main matrix, and all the element of this matrix must belong to the main matrix, so that matrix is known as the submatrix. Here the main matrix is this, and all the element 1, 2, 4, 5 belong to the main matrix. So this matrix must be a submatrix of this main matrix. And what is the principal submatrix? Okay, 3, 2, 5, 6 is also submatrix. 1, 2, 4, 5 is also submatrix. 1, 2, suppose 1, 2, 4, 5, 7, 8. All these element belong to this matrix. So this is also a submatrix of this. But this is not a principal submatrix. Why this is not a principal submatrix? Because a principal submatrix will always contain the diagonal element that are the diagonal element of the main matrix. Here you can see the submatrix of order 2 cross 2 having the diagonal element 1 and 5, and the diagonal element of the main matrix is 1, 5 and 9. So 1, 5 and 9. So you can see 1, 5, 9 are the diagonal elements of the main matrix, and the submatrix we created have the diagonal element 1 and 5. So if its diagonal element are also the diagonal element of the main matrix, then it is a principal submatrix, whereas this is not a principal submatrix. So this is only a submatrix, but this is a principal submatrix because its diagonal element are the diagonal element of the main matrix. You can see 1 5 is also diagonal. This is the concept of principal diagonal or diagonal element and principal submatrix. Let us learn about diagonal matrix. So guys, let's learn about diagonal matrix. So what is diagonal matrix? So a diagonal matrix is a square matrix whose diagonal are only exist. Okay, so if I want to say the definition, so a square matrix in which all off diagonal elements are zero. Off diagonal means elements beside the diagonal. So this is on diagonal elements and all these things are off diagonal. So a square matrix in which all off diagonal elements are zero is called a diagonal matrix. So a diagonal matrix must be a square matrix and the all elements other than the diagonal elements are zero. That is known as the diagonal matrix. Okay, and what? So if you learn the diagonal matrix, you will also learn the scalar matrix. What is scalar matrix? Scalar matrix. If it's called a scalar matrix, a diagonal matrix is said to be a scalar matrix if all the diagonal elements are same. Okay, so if suppose 3 0 0 0 3 0 0 0 3, so I have made a scalar matrix. So if you want to learn the definition of scalar matrix, a scalar matrix is diagonal matrix with all diagonal elements being equal. Okay, so here you can see all the diagonal elements are equal. So so let's conclude these two things. So a diagonal matrix must be a square matrix in which all the element other than the diagonal element are zero. A scalar matrix is a diagonal matrix in which all the diagonal elements are same. So a scalar matrix must be a diagonal matrix but in which all the diagonal elements are same. Okay, so guys, at first we learn about the square matrix. So square matrix means a matrix in which the number of rows equal to the number of column, and after that we have learned about the principal diagonal and principal diagonal element, and after that we have learned about the submatrix and principal submatrix, and then we learn about the diagonal matrix. A diagonal matrix means a matrix in which only diagonal element exist and all other elements are zero. Okay, and then we learn about the scalar matrix. A scalar matrix is a diagonal matrix in which all the diagonal elements are equal or same. And now we learn the unit matrix. So as the name said, unit means unity, means one. Okay, so a unit matrix is a diagonal matrix in which all the diagonal elements are 1 and all the other elements are 0. Or you can say a unit matrix is a scalar matrix in which the diagonal elements are 1. Okay, so it's better to say a square matrix in which the diagonal elements are 1 and all the non-diagonal elements are 0 is called the unit matrix, or it's also known as identity matrix. Okay, and guys, learn this identity matrix very carefully because we will only learn the properties of this matrix, and we will in further in coming theory portion of this linear algebra will mainly deal with the unit matrix or identity matrix. So a identity matrix in which all the diagonal elements are 1. Okay, 1 unity, and all other off diagonal elements are 0. So guys, let us learn some properties, okay, of diagonal matrix. So, and I want to say one more thing, that is the identity matrix is denoted by I. Okay, this is the principal rule, that you cannot denote identity matrix with any other matrix with any other letter other than I. Okay, it must be denoted by I for identity. Okay, so here I want to say some properties of identity matrix. So first property is, so first property is, suppose a matrix I, if we multiply a matrix, any matrix with identity matrix I, it will give the same matrix. Okay, if you multiply any matrix with identity matrix, it will give you the same matrix. Okay, it will also be written as IA. Okay, so if you multiply any matrix with identity matrix, it will give you the same matrix. So guys, please remember this property. You can get the short question in GATE from these properties only. Okay, so if you remember this property, you can easily do that without going to the calculation part. You don't have to calculate if you know the properties. And second property is, this is first property, and the second property is, any identity matrix of, if we multiply any identity matrix in any time, okay, so it will give me the identity matrix only. Okay, so it's better to say, if we multiply any identity matrix with any number, okay, not any number, with any number of identity matrix of same order. So if I put in of identity of nth order, so it must be an identity matrix. So the third property is, the inverse of identity matrix is identity matrix. Okay, so I have already told you that in matrix portion, the inverse of matrix and how to calculate the inverse of matrix is very important. So for identity matrix, the inverse of identity matrix is identity matrix itself, and the determinant of identity matrix is 1. Okay, is 1. So if you want to calculate the determinant of this matrix, of any identity matrix of any order, it is the order of 3 cross 3, it may be 4 cross 4, it may be 2 cross 2, or any order. It must, the number of row is must be equal to the number of column, because a identity matrix must be a square matrix. Okay, so I have already told you that we will mainly deal with the square matrices. So we'll learn the different type of square matrices and we'll manipulate them. Okay, so the determinant of any identity matrix is 1. So let us guys know some more special matrices, and after that we will learn the matrix operation. Okay,